So welcome everybody to Lecture 8, Databases and Information Systems, which can also be taken as information retrieval. And today's lecture is about web applications, part 1. So, but first we will talk about your experiences with the last exercise sheet, which was about fuzzy prefix search. And I have a slide about the infamous AYSA folder. And I'm curious about what you will answer to my question. And today we will talk about how to build a search web application with a lot of live coding. It's a very demanding lecture and I need your help. I hope we won't go over time. I don't think we will, but let's see. And the exercise sheet will be to build a web application. Actually, it will be 2 exercise sheets now before Christmas. We timed it that way deliberately. So first a simpler one, static application, and next exercise sheet, a dynamic application, which will sort of integrate everything we have done so far. And since there's always a few people who say, why are we doing web applications in a lecture about information systems, databases? Well, I think basically every information system has a kind of web interface. Even your mail program, which is also a kind of information system, has a kind of a web browser inside JavaScript and so on. So it's really a must to know this kind of technology when you build any kind of information system. First, back to the previous sheet, which was about fuzzy search. Here are some quotes, nice lecture and well-crafted sheet. So very sorry for the overtime. I have to see for the next time. It was a little much because maybe the edit distance, so much interesting stuff, it was a bit much. Explaining the edit distance, explaining the mathematics, and then how you do it, I have to see about that for next year. I think it's a bit too much for one lecture. Nice lecture and well-crafted sheet about an interesting topic. Many of you said it's very interesting topic, very enjoyable and instructive exercise. Took around 10 hours, so as usual, there's a wide spectrum of how much time people take for this, depending on your experience and just your, depending on a lot of things. Less work than previous sheets, took about 4 hours, so you see the spread. My first implementation had quadratic runtime. Telling from the comments on the forum and also in the feedback, several of you, I think, had that problem that even for the small data set, it took very, very long, and that's typically an indication of something quadratic going on, or worse. Would be more exciting to implement prefix edit distance myself. I agree, it used to be part of the sheet, but then it would be even more work. That's why like every year we provide more. And it's still challenging, I think. It's cool to get to know how fuzzy search works, I agree. The mathematics behind this is still confusing to me. Yeah, please look at it for the exam, it's important. I think it won't be okay to just tell you, here's the algorithm, use this formula, then it works. I mean, we have to explain the mathematics, right? I mean, it's not like deep mathematics, but you have to understand what's going on. It's this interesting kind of mathematics which is very close to the algorithm. I mean, you just need this formula for when do I need to actually compute the PD, or when can I filter it out by just looking at the Q-grams. You just need that formula, and so you just have to do the math. It's actually a great example of how the kind of math you very often need in programming. I mean, you just need the formula. When do I have to compute the PD? And the better the formula, the less computations you have to do. So the math here is really important. Tricky one, nice challenge as usual, but also a bit much. Some of you wrote that, not all of you. A little complicated to understand. Yes, it was not easy. Okay, and I think I wanted to show you, we will do a lot of coding, but maybe first let's go back to the master solution. So let's maybe first, this was the file we gave you. So if you wanted, you could only look, or mostly only look at the first column, which was just a lot of entities from Wikidata, and you will also be working with that, you will be using that. Let's just look 1.6 million about. And let's just, I think I just tried it. So let's just try it with font is one smaller today because otherwise it won't work with the coding we will do in the following. I hope you can still see it all right in the back rows, but you have still young eyes. For the video it works fine, I tested it. So you can see it's a not so small file. It takes some time. What you see here is Python. I mean, Python is just it's a convenient language, but just very slow. So let's just, in the meantime, how big is this? Solutions, sheet 8. Why? There it is. No, sheet 8 is not yet there. I'm sorry, you have to do it. Yeah, it's 269 megabyte. That's not huge. Terabytes is huge. Here it is. Let's type something. Let's type Freiburg. Okay, that was too many. Let's type Arnold Schwarzenegger. Didn't even make a mistake. Okay, let's anything. I don't know. Forrest Gump. Okay, I'm making too many mistakes here. Forestry. Okay, Forest Grove. Forest Gump. Okay. Freiburg and Breisgau. It's really fast because the PED computation was done in. So, yeah, let me maybe Freiburg im. Okay, so I can't make Freiburg. Yeah, this works. So I can certainly make some mistakes. Frieb, that's too many mistakes. Fribourg. The longer with the word, the more mistakes were allowed. Fribourg. That's interesting. Because if you make if a transposition is 2 edit distances, so apparently, don't we allow 2 errors here? So I'm a bit surprised that we don't get Freiburg and Breisgau here. I don't see anything. I see, it's because PED with 1 comes first, that's the reason. Okay, it's interesting, that's the ranking here. The ranking was such that you first get the hits with a prefix edit distance of 1, even if they are less popular. So anyway, you see that it works, but you can play around with that for the next exercise sheet because you will also use this. We will see in a second. But it's pretty fast and it works. So you can just, if you don't make any mistakes, it's just there. So pretty cool that you could do this in one exercise sheet. Okay, back to the, let me just go back to the folder where we will be in a second. The AY, are you still active folder? It was actually very hard to get all of you react, and now I'm interested about what you will tell me why. We sent an official announcement, so there's this forum official, and we said in the first lecture that you have to subscribe because it's the official announcement. The topic was prefixed important in capital letters. It was sent on November 15th, and there was a mail via HIS-in1, campus management system. And there was a reminder of November 24th, or maybe 27th, I'm not sure. Doesn't matter. And then I sent another reminder with the prefix very important in capital letters, and I put the word exam in the. So I thought maybe it's a good idea to put the word exam on December 6th, again via Daphne and via HIS-in1, so that before this last reminder, which was the third one, about 100 people did this, and we were a bit suspicious. Is it really only about 100 people who will take the exam? Because there were over 300. I mean, initially always a lot of people sign up, and then it usually reduces by about half or not quite half. So 100 looked a little bit small to us. One day after this one, it was 200, which means there are 100 people who needed this third reminder with very important in all caps and exam. And we were trying to understand why is that? Is it these 100 people, they're basically not following and you just have to take extreme measures to take I mean, we are living in these times where you have to take extreme measures to get people's attention, but still. So if you have any, I only got the mail, okay, here get some feedback. You only got the mail on 6th of December. First mail never arrived. There should have been 2 mails before. Okay, interesting. Here some of you wrote something about this, even though there was no question. I almost never look in the forum. That's of course a mistake, because official announcements are official announcements. I agree. I thought about this. I think I basically I forgot it to mention it on the sheets or in the lecture. And it has a build error on Daphne. Yeah, that's correct. We did it like an exercise sheet so that you can that we can see on Daphne who did this. Okay, anyway, interesting. So now on to the topic of the lecture. It's a quarter. Yeah, let's just dive right in. Oh, you have a comment about this one? Yes, please.
Yeah, I just looked up, so I also just got the last email and never one of them before.
Okay, but you didn't subscribe to the forum, right? Because that's for sure that this post was posted on the forum.
No, not the one on the forum, but the email.
Yeah, but if you subscribe on the forum, I mean, there are 2 issues here. Let me just clarify that. I don't know if it works. Thank you for the feedback. This is the forum here. And if you subscribe, so here's important, very important. Here you see fire. What exam I have to... So if you subscribe to this forum, you get an email. So if you didn't get an email, 2 things happened. You didn't subscribe to the forum, that's for sure. And the his in one mail somehow didn't work, which we sent twice. Anyway, interesting experience. Let's move on to the lecture. And thank you for your feedback. So, web applications. We are going to build a web application today in the lecture. A very simple one, but even building a very simple web application requires understanding of a lot of things. Simple things, but a lot of things, and when they interact, it's not so simple anymore. Super exciting topic, if you ask me, and an absolute must to know for information systems, but for computer science. Everything has a web application in some form. The basis, socket communication. What is socket communication? First, a few slides just about what it's about, and then we will dive right in to the coding. Socket communication, you have 2 programs, processes talking to each other. That's obviously important when you build a web service. Typically, they are on different machines. They can be on the same machine. Thank you, Frank. For a typical web application, it looks like this. You have your browser here. Type something in the browser, for example this, and now this browser talks to our machine where this wiki is hosted, gets the web page, displays it. So here you have a browser just running on this machine right here, talking to our web server in our group, which returns this page. And there are static web pages, we will do that today, and then there are dynamic web pages where on the web page you have code which is executed and also communicates with other machines. That will be the next lecture. So you have this machine-to-machine communication, 2 endpoints, like 2 people talking, then the people are the endpoints. The endpoints are called sockets. On each machine you have a socket. And each socket belongs to a particular machine and also has a unique ID, because that machine at the same time can talk to a lot of things. Unlike humans, who are not really good at multitasking. And that unique ID for a particular channel is called a port. So you have a machine called a host in this context and a port. And there can be many different channels open at the same time. So you have many different ports. And as we will see, a port just has an integer ID, like 8512. Here's a very basic protocol, which we will also use today, which is also how the basic web application protocol works. On the server side, so you have a server, for example, the machine hosting these pages, our wiki pages. And there you create a socket like an endpoint so that people talk to you, and a certain port. So please, you can call me under this number on that machine. And then you just listen on that port. You're sitting beside the phone and waiting for someone to call. You wait. If someone calls, you hear what they want. You do your work. They want something. You have to fetch a file, compute something. You send it back. You wait for a call. You send something back. How does it look like on the client side? Client is, for example, the web server. The web server wants this page from our machine, calls up the machine, needs to know the machine and the port, and then this then gets also a port automatically. If this web server calls someone, it doesn't have to say which. It is not important which port. It just needs to tell the server the port. And this is somehow done by the operating system. We will see that in a second. Then it sends its request, waits from the result for the server, and does something with it. Protocols can be much more complex, much more dynamic, but that's kind of the simplest one. You call somewhere, you say, this is what I want, and the other side takes the call, does something, gives you the result, over. Next. That's what we will do today, and that's also how web applications, basically, most of the time, that's enough. So we have the server side, the one doing the work, and the client side who wants something. All programming languages have standard libraries for this kind of communication, for the server and for the client. In Python, the library is called socket. In Java, server socket. In C++, Boost ASIO. For asynchronous I/O, it's not in the standard. It's pretty complicated stuff, all this network stuff. We will see a little bit of it. We will provide for the exercise sheet today, and maybe let me show that to you already. I did some preparation, so that's the kind of code you will get for the exercise sheet. I will write a lot of additional code with your help today, but then I will not give it to you, because if I give it to you, you can copy it and you have half of the exercise sheet done. And let me address two issues here. First, why don't we give you that code? And why can't you just use HTTP library in Python, right? There's a library for building web applications. And with that, 80% of the exercise sheet would be done. But then you don't learn anything, right? To really learn how this works on the lower level, and that's the point of university, right? Understanding how things really work. You have to do this yourself at a lower level, not at the lowest level, but at the level I'm going to explain in a second. So it's really important, there are also always exam questions about this, really important that you understand this. Of course, in the future, then if you have understood the low level, then you use frameworks, but for the exercise sheet, you need to do it yourself. So that's what's written here. So we will just provide this very basic, it's a small file, I will explain it in a second, and from there you go. So here's some basics. Let me just, this is also in the file, I will just explain it on the slide. So yeah, you use this socket library, we will do it in Python. You say, I want a socket, you have to say, okay, internet. You have to set some options. This here is important when you start the program again, that you can just reuse the same port again, otherwise it takes some time for the operating systems to clean it up. These are a lot of annoying things, small details. If you don't do them, you have so many small details, we just give them to you. This is important. I mean, you're running on your local machine. This means basically anyone can connect, no matter how they call you up. You have an IP address, a telephone number. Machine also has a name, different ways to call a machine, name, IP address, many IP addresses, many names. This basically says, however you call me, I will react. It's also an annoying detail if you don't get it right. The port, I just explained it, and then you say, okay, I'm ready. Listening. Then this is how you accept the connection. This just waits. In the standard mode, this is blocking. I'm just sitting near the phone and waiting. And if someone called me up, then I have a connection object now with which I can work, and the address of the client, IP address of the client. I will not explain a lot of there are layers, many layers below this, all the low-level network stuff. This is not a network lecture. We will not talk about that. That's also important. Maybe someone calls you and then there's no one on the other side, just heavy breathing or no breathing or I don't know what. Somehow I have to say, okay, if nothing happens for 5 seconds, I will move on to the next. Especially important for our code, we will not do multi-threading today, right? Normally what you would do, a lot of people are asking you and then you have like 10 threads waiting for requests, or if you have a request and you work on it in a separate thread, you're ready to work on the next one. We will just do it single-threaded, one after the other, which means if someone is not talking to you, we have to somehow cancel this after some time. Otherwise, your whole server it does not go on. Somebody calls you, doesn't say anything, and then nobody can talk to you anymore. We will see that in a second. Then you read the request, and then you do something, you send back your answer, and you close the connection. That's the basic server loop. We will implement it in a second. This one is important. Let me say it already now. Remember it. We will implement it in a second. When you listen to what the other side is saying, it's network protocol, they are sending to you, maybe they are saying something, think of it like a phone call. They are saying something, then they are saying something more. When do you know that they are finished, right? You somehow need to, there's no universal end of message. When you communicate with people, it's kind of, when somebody makes a longer break, you know that, now they are finished. Usually they don't say end of message, now you can speak. We have some cultural norms for this. In the computer world, we have to agree on something. But it's important that you not just read once, but you say, okay, is there more? Is there more? Is there more? We will see it in a second. And on the client side, we will not implement the client side, just the server. And we will see that. Let's start coding. And let's see how that works. Okay, and I have a lot of windows open here, and you will see in a second why. Okay, so let's do the server loop. Okay. So the server loop is wait for requests and process them. And we do that. That's the typical server loop. It's kind of running forever. So I'm a server forever. I will just, So let's just wait for incoming request. And we have already seen that on the slide. And we, let's just write that we are incoming. Let me maybe put that on the top. Waiting for incoming request on port, and I think I want a formatted string here. That's a bit nicer. And let's put a space here. So I'm just waiting, and how do I do that? That was written on the slide. It's just, okay, I get the client connection or socket, let's call it socket, the client address, accept. This is now blocking and waiting for an answer. Okay, and so if somebody replies, let's just say, okay, we received something from this request. Okay, great. Let's already implement that, and let's already run that, Okay, so and here what do I get to start my server? It's called search server.py. That will be on the right. Let's just see. I just have to specify the port. That's where I can be contacted. Let's just take 8080. Okay, waiting for incoming request. I think I want a new line here. So that it's a bit nicer. We will see this a lot. So I'm waiting. How do I call this machine now? I have a third window here, And one very simple program, is it on the, yeah, it's on this slide. Just for testing, that will also be useful for the exercise sheet. It's a very old program, Telnet. Telnet is just call up this machine, pick up the receiver, call this machine. Call the machine so-and-so on this port. Let's just do that. And here on the right we have, so I'm just doing Telnet. The machine is called Tura. I'm also on Tura. I don't have to be on Tura. Let's go to some other machine here. I don't know. We have, let me go to Indus. It's one of our, we have a lot of machines. Let me call up Tura on port 8080. Ring, ring. Okay. Yeah. So, received request. And you see what's, yeah, so this 108152. This is Telnet. Let's maybe briefly exit Telnet again. It's not so easy to exit Telnet, but it tells you that it's one of the hardest problems, how to exit certain programs. But it tells me here what the escape character is. If I take this email address here, that should be, yeah, that's the, I think I have to ask for the host name here. Yeah, that's Indus, that's a machine. So a machine has a name and an IP address. And you see the machine from which I was calling was also getting a port. That's the port now on Indus, on this machine, 55700. Okay, let's go, let's call again. So, and you see, so let me just, hello, hello. Yeah, a lot of things can go wrong in communication between humans, also between machines, right? I mean, this has already moved on. We see it here. It's waiting for the next request because we haven't implemented it yet. So nothing is happening here. I can talk all I want. Nothing is happening. So we obviously, let's just continue with our code. A lot of things can go wrong, right? The client can ring up and then the server just moves on or died or whatever. The client just hangs up again, starts a little bit, then something goes wrong. It takes a long time. Okay. So now we read. Let me just read bytes from the client in rounds. This is what I said earlier. It's very important. And here's another very important slide. Bytes versus strings. This is very important for the sheet and also for what we are doing now. The data sent via the network is always bytes. It's just bytes. That's important. In Python, how do you deal with bytes? There's bytes and byte array. Bytes is immutable, you can't change it. We don't want to change our objects here. It's not that we receive something and then we don't want to change. So we can just use bytes. Don't need bytes arrays. But usually you want strings. What's the difference between strings and bytes? Well, here's an example. Knödel is a string, right? Ö is a German umlaut, and when you represent it in bytes, you somehow, for example, in UTF-8, we will talk about that in the next lecture. How do you encode funny characters in bytes? Well, in bytes, the Ö actually is 2 bytes. So it's the byte with the hex code C3 and B6. And this is how a bytes object, you can, in Python, you just write like a string, but with a B, prefixed with a B. So this has actually, Knödel has 6 letters, but Knvl has 7 bytes, right? That's very important. Very important. Great source of errors. That's the other way around. So the functions in Python are called, and you need them, encode and decode, turning a string into bytes or turning bytes into strings. So here I have bytes, 2 bytes, which are just the German umlaut Ö, same as here. And if I decode them, now I have to say, okay, which encoding are you using? Whole next big part of next lecture will be about this UTF-8 because it's super important for every information system as somehow has to encode text. And so you have to say, how do I encode all these funny characters in bytes? So here, if I use this encoding scheme, I get back a normal string Ö. So this is a string with 1 character, length 1. This is a bytes object or a sequence of bytes of length 2. And you need to convert between the two. All the network communication is bytes. What we actually do is string. So here we are. So my request is just, it's something like this. And while what? I mean, now we have to read next part of request. Okay. So yeah, and let me do it like it's a byte sequence. I think one way. So it's just a receive function, and let me just do extend here. If you want to append to a byte array, I think it's called extend. And then you have to say how much you will be reading at most in one batch. But it's very important that you... And now we need to agree on a protocol. How long do we read? When do we say, okay, now and let's do the following. Let's just wait for a new line. Let's wait for find, and let's do that. And we will see that in a second. This here, that's carriage return and new line. That's how Windows encodes new line as 2 characters. Carriage return, that comes from the typewriter world, where the carriage on the typewriter goes back to the left, and then new line is go to the next line. That's why it's 2 symbols, in case you didn't know, right? On the typewriter, you have this carriage, you have now typed, it's over here. You have to get it back and to the new line. R is the carriage return to the first column, new line, next row. And that's also in a web, you use that for. So that's just a new line, and that's another new line. So this is basically saying empty line. So let's just do that until I find an empty line. Okay, and now let's convert that to request is, let me just, I want to decode that in UTF-8, and let's just print it. Yeah, let's print it and request was request. Okay, let's see where that goes. Let's just start our server here again. And where's our telnet? Here. Okay, let's call again. Okay, what did we do wrong? Bytes object has no attribute extend. Okay, what did I do wrong? It doesn't have extend. Then what do I do? Is it plus equal, or let me try plus equal. Okay, this seems to work now. Let me call again. Okay, let's say hello. Okay, our protocol was this is receiving, waiting until are you talking to me? And now let's new line. Okay, that worked, right? Request was hello, are you talking to me? Until I typed. And now again, you see this connection here is closed. The server moved on. Here it hasn't moved on. Yeah? Okay, here is my request. Yeah, it's not talking to me anymore, right? Somehow we didn't agree on the protocol. So here it already moved on and so on. Okay. And let's do another thing. So we have settled that. And now where do we... And okay, let's go on to the next stage. So now we have a basic protocol established. Now, okay, I think now it's time to. So we use Telnet, but actually a browser is doing is also a kind of. It also calls up other machines. So this is running on Tura. This is now internally, so I can also just write Tura here because it's in our network. Let me just write Tura 8080 here. And that's When you type in the browser the name of a machine or an IP address, :8080, what you're saying is call this machine on this port. Let's just do this. Bam. And you see, something is happening here. So now this is just the same thing, right? Now it's not Telnet that was calling me, but the browser. Tura 8080 is just say call the machine. It's like Telnet Tura 8080. And you see, it sent something to my machine here. It sent this whole thing. We'll explain it in a second. And the important line for us, we will ignore everything here. That's all kind of header information, additional information, cookies, a lot of interesting things to understand here. I think we'll mostly ignore it today. First line is important for us. How does a web address typically look like? Typically I have something here, right? Machine port. Usually you don't specify the port. If you don't specify it, it's implicitly 80. Right? 80 is, if we do Wikidata Q80, that's Tim Berners-Lee. Yeah? Q80 is port 80 of HTTP. So let's, but we specify the port here with a colon. If we send this, now what do we get in the first line? Now we get, right? So everything you type. So that's what a web address basically is. It's the machine, it's the port, and then some information I send. So this is now sending here get, and then do something with this, please. It's telling the server, do something with this string. And here that's the name of the protocol. We talk about it in a second, and so on. And you see, why is it still, what's going on here? Why is this bing, 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 ping pong here? And nothing is happening? Yeah? Yeah, it's not responding, right? It's easy when it's explained like here, but when you're doing it, this can be hard to explain, right? My server already moved on. This thing has no idea. This is on a different machine here, right? It's on a different machine and still waiting for a response. It doesn't know that the server, this web browser doesn't see this window. So in networking, it's simple in principle, but so many things can go wrong. Now let's talk a bit about HTTP before we continue with our implementation. So now we are talking about machines talking to each other in the context of a web application. And so the protocol there is called HTTP, how we talk to each other. And it's a basic request response protocol. And yeah, we have already seen that. So this is how it hosts port, and then it sends something. This is also, we have already seen this. It sends, so if you add something like this, and typically you add pages, this will be sent to the server. And let's send back a result now. Okay, now you have sent back a result, and if you send back a result, maybe let's first send back some result. Let's go back right to the coding. Let's, so what do we do now? Handle the request. I'm sorry, and let's handle the request in a separate function. Yeah, I think that's a good idea. So we have a separate function here which handles the request, where we do, and this is self, just because it's a method of that, and it gets the request as, okay. So this handle the request and return a suitable response. It's kind of, so what, yeah, let's just do something. Let's formulate a response, and let's just say a response is, yeah, thank you very much for, let's just be polite but lazy. Thank you very much for your request. Okay? That's it. That's our response. And we send it back. And let's, do we send it back as bytes or, yeah, let's, as bytes. Let's send back our... Yeah, I'm not sure. I think I want to encode it here. Response is equal to... Yeah, I want to encode it and then I don't need this. Okay, now I get my response. I'm not sure if I need 2 lines here. So this handles the request. And now we somehow have to send it, send the response. So how do we do that? We saw it on the slides. It's just send all response. That's correct. And now we should close the connection and move on to the next one, and that's just close. Okay, now we have implemented the full server loop in a very simple form already. Let's just see how that looks. So I'm reading the request in rounds until I get an empty line. And we already saw that's exactly how HTTP works. It kind of, that's the convention used in HTTP. Read until there is a completely empty line. So we already implemented that. And then just send back a stupid response. And let's just see how that works. Let's go back to our browser here and let's just send the same thing here and bam. Okay, we get something here. Thank you very much for, oh, I'm sending back the whole request. Okay, let's fix that. Actually, the request was not only this thing. I mean, we're really only interested in what's after the slash here, right? But we get this, we get and the protocol name and all these headers. Let's forget about all that. Let's just extract this part here. Everything before the protocol and after the get. We also don't want the slash. Let's just implement that. So, yeah, extract the part we are only interested in the first line and the part after the get and before the HTTP /1.1. Okay, let's see. Yeah, let's just split it by, yeah, we know that there's a new line. Let's just take the first line. Let's split by the space. Yeah, we just want a space here. That's very reasonable. Okay, we also split, yeah, that's one way to do it. Okay, there are many ways to do it. Let's just try that. And let's just print the request after this. Request yeah, it's not, I don't know what's there. There's a name for the thing after the request part after get was blah. And maybe, yeah, let's maybe put this in a try block. I think that's safer in case. No, you can put that in a try block in your, you should do proper error handling. We don't have to do it now. I mean, maybe I get a different request. We'll see that in a second. Maybe it doesn't have this format. Then, of course, it shouldn't crash. It should output a proper error message and so on. Let's just see how that works. I'm just explaining the basic here. Let's try the same thing. Oh, yeah, this worked. Request part after get was, let me write it a little bit. Yeah, get request for, I think that's a nice, that's called a get request, what we received. So the standard is a get request, give me something. Let's just do that again. And we're already getting closer to something real, right? Get request for blah. So this is exactly the part after the slash here. I'm sending back an answer and I see the answer here. So we have already a simple web application. Now, some very interesting stuff here. I now press F12. Let me see if it's on the next slide. F12, the browser development console. I mean, this is just, you have to know this, not only for this exercise sheet, but for the rest of your life, for everything. You just need to know that your browser has this development console. And here it is. It's now F12. I open it. You can have it on the right or on the left or at the bottom. I have it at the bottom now. And this is like a huge tool. And we just, a number of things will be interesting. The console we don't need now. The network tab will be the most interesting now. The network tab, this is a browser and it's talking to other machines. That's what browsers do. And this is just saying what's going on. Let's just do reload. And now we see, it sent 2 GET requests. And we see a lot of information here, all of which we will be going to understand. Why did it send 2 GET requests? Let's first look at the first one. That's the first one. And so here it said, I sent to Tura 80. It's maybe a bit small. Let me try to make it, let's see if there's a lot of information here. So yeah, that was one larger. So it sent a GET request to Tura on port 880 with this. This is what we did. And here are the request headers. This is exactly what we saw when we didn't extract the first lines, right? This is what it sent. GET, it's HTTP 0.9. Wow, this is an old browser. HTTP 0.9? I'm surprised. I don't know what it's. Okay, but my code worked anyway because it just split by HTTP. Anyway, I can also see it in raw form. So it's really just sending that text. If I don't do the raw form, it's actually just key value pairs, right? These headers. So it sends all kinds of key value pairs, the meaning of some of which we will learn, but we can ignore most of them. And then there's a response, which we can see here, and that was the response. Thank you very much for $. Why is there a $? Did we send a $? There was a $, in our code, apparently, right? Handle the request. Oh yeah, there was a $, here for some funny reason. Anyway, so that's the development console. We can see what's going on. Actually, we didn't do this properly. And let's just see that. If we go back a few slides, the way we are supposed to do this, we are not just supposed to send some contents, we are supposed to send headers. Just like the request had headers, the response should also have headers in the HTTP protocol. And these are the minimal headers. Somehow say, okay, this worked fine. Then say, I'm going to send you a message. It's of this form. We will see more about this in a second. And it has these many bytes. So let's just do that in our code. We want to write a proper web server. So now we compute the headers. So we want the headers. Let's start with, let's take HTTP1. Okay, let's add the content length. Okay, that's fine. And let's add the text plain. So these content types, let's maybe go back to the slides for a second. Content length, it's clear. It's the length in bytes. The content type. What are the content types? These used to be called, this comes from the mail world, I think originally, multi-purpose internet mail extensions. You send something via mail, you have an attachment, you have to say what's in this attachment. It's just encoded as a sequence of bytes. What is it actually? So this used to be MIME, then in web context it's called content types. The correct modern name is media type. What kind of thing is this? And the way you call this is always, it's 2 parts separated by a slash. So the first part says what is it in principle, and the second part is more specific. So here we have some text format which says this is just text, it's just considered as a string. Plain, this is just text like what I sent so far. HTML, we will see in a second, this is text with a special meaning. For example, program code is text with a special meaning. HTML we will see in a second. Maybe you also want to send an image or code. Application is all kinds of code. So you just have to know these. It's not hard, right? You just have to understand there's this convention of calling things. Text plain, this is what we want here. And okay, let me also, and the headers, yeah, let me also encode I'm setting, yeah, they should also end with an empty line. And I think we want to encode them as bytes. That's exactly right. And now we want to send back the headers and the response. So let's do that. So now I did the same thing, but I'm sending back. So now, will we see the headers here? Let's see if we run it again. No, I get the exact same thing here, right? Nothing changed. But when I look here now I also get response headers. Here are the response headers I sent. 47 and text plain. I can also see it in raw. This is exactly what I sent, right? I just sent headers, an empty line, and then the actual content. And again, note, I need some convention so that my other side knows when it's done. That's why I send the content length, right? Otherwise, the other side doesn't know, will there be more, will there be more? For the request, I did it like this, that I just waited for an empty line. I can't do it like that for the response. The response could be anything, empty lines could be part of the data. So the way it's done there is like saying, okay, I will send you some headers. There are a lot of different headers. Then I will send a new line, and one of the header will say exactly, I'm going to send these many bytes, and then I send these bytes. And these are the bytes, and this is the header. And here it only displays the bytes, and in this case it's text, so everything is fine. And here it also says the OK. And by the way, I think it's totally arbitrary what you write here. You can also write alles supi. Let's see if that works. So it's very simple, this HTTP. Let's just see whether that works as well. Yeah. Okay, now it says alles supi. Yeah, you see that it actually worked. It doesn't really care about the string, right? The 200 is important. And that's really interesting if you do it on this level yourself and then understand actually running it and seeing what's happening here. That's the way how you really understand this stuff, right? Not if you used a HTTP package by Python. Then, and there are a lot of things. Now, so far, everything worked fine. There are a lot of things which can go wrong. And these things in particular you have to understand. Let's maybe look at why is it sending this fef icon. Okay. Oh, it's also getting something. So fef icon is, I think you're welcome to implement this. Let's go to some, let's go to Wikidata. You see this little picture here? Browsers always like to show little pictures here on the tabs. Some people have many tabs open, and it's good to know what's running on this tab. So you have these little icons here. And this is something, where does the web browser know this icon from? Well, it's asking the server to provide the icon. And so it's always asking fef icon ICO. So if here I would change my server to return this, then, so I'm returning something, but I'm returning, I'm sorry, if I go back here. Yeah, I'm saying thank you very much for fef icon ICO. So it's not exactly, so that's why I don't have a little icon here. If you feel free to do it for the exercise sheet, also return an icon to that request, and then you will have a nice icon here. So let's see what else we do before the lecture, before the break. let's go through the slides once more. So we did this, we received a GET request, we sent back our reply with a header, and then the contents, this I already said, HTTP once new lines encoded like this, carriage return and n. We only do, just a second. We only do GET requests. There are many other request types. POST requests. This I think it's worth to talk about for one sentence. With a GET request, you're writing it in the URL, and then you have, it's like short requests, things which fit into URL. What if the browser wants to send 1 gigabyte to the server? This doesn't work with the URL. There's actually a limit here. This you do with a POST request, and then you can send arbitrarily large data, but with a slightly different protocol. Many more headers. So request types. We will not talk about them here. Then there are many more headers for the result. So not found, for example, we just sent back 202 for 200, okay. Not found, forbidden, and so on. You should implement at least 404 and 403, and we will implement one of them, I think, in a second. We already had the media types. We already had the development console. We will see more about this. Today we will only look at the network tab. We will see about that in a second, and console will also be very important for the next lecture. Okay, and I think that's a very good point to make a break, and we resume in 5 minutes. So let's continue. So far, time management was perfect. Let's not spoil it for the rest. I don't know what's going on. So as you can see, we are already over the middle. And that was the hard part, actually. So let's see. And please do ask if you have any questions. Let's go back to the slides. So now we have established, so what have we done? Quick recap. We have a server here. We can start it, and in the web browser now we can talk to it, and it reads the request here. It gets 2 requests, one the actual one and one for the icon, which we don't provide. We return the answer, we do it in proper format, it displays it, but so far it's meaningless. And for testing, we can also do this one more. You can also do this here. Interesting. This doesn't. So yeah, you see, I didn't do proper error handling here, right? I was expecting a GET request. Let's maybe do that once more. If I would stick to the protocol, it would work. I could also send a GET request here. Blah, blah, HTTP 6.5. Now it works, right? And now I get the reply. So this is, so I can play web server here in Telnet, right? I just have to send it in the right format, which my server wants. And now I received this result. So not bad. And now HTML. HTML is, when I want to display something in the browser, a bit more nice than just text. That's what HTML is about. It's a very simple language, XML-like, so it has these tags in these angle brackets. We already know them from Sparkle. And let's just write a very simple web page now. This is, there are some basic elements. So there's this header section, which has meta information, and body is the actual contents of the page in HTML all around it. So in the header, you can have things like, we will talk about it in a second, a style sheet. Maybe you want to give it nice colors or fonts. Code, we will talk about that in the next lecture. And in the body section, the actual contents, you can have things like So it's like semantic markup, right? You don't say, show this in this font size from this font family. You say, this is a first level heading. This is a paragraph. This is an input field. So these tags are semantic information, not formatting, not low-level formatting information. Let's just start by writing something. And now it's not hard, but it gets more stuff now. We now create a different file. So search HTML. Now I'm creating an HTML page. And let's just, so I'm starting by HTML. Here I have a head. Let's just choose an empty head for now. And now a body. And now let's do a first level heading, my first search engine. Okay, H1, and then I finish the body. So that's very simple. It's always good to, and then HTML, done. Damn. Okay. And now we want to deliver that with our web server. Now how do we do that? And it's called search HTML. And what we want now, and that's the typical thing what web search, how this works. Here I want to type search HTML.html. And what I want, I mean, I could do it now, and it says, thank you very much for search. That's how I programmed it so far. What I actually want my web server to do, and that's the typical mode, is please look up whether you have this file on your machine and then serve it to me. That's the typical, that's how the web worked in the beginning. Asking for static files, and then they were served. So I have this file here on my machine. And let's just extend our code to do that. So we are in the handle request function here, and let's just oh, what did I do now? Something is so let's interpret the request as a file name and see, read the file if it exists, and return its contents as response. So now we are. And if we have done that, it's a real web server. Okay, let's, so how do we do that? Let's just, think we should start by writing a try block. Okay, yeah. So we try to open the file. So we just take this as a file name, and maybe a file name request. I think that's more meaningful, and let's just write that again. Yeah, so I'm just reading the contents, okay, and yeah, file read. Will it return the contents in bytes? I'm not. Yeah, if it was not found. Now what do I do now? Response file. Okay, let's just do that. File not found. Let's just try it and see. So now I'm just, I try to read this file. If it exists, I read it. That's my response. And let's just see how that works. Let's just go bit by bit. That's also a good way. And yeah, and now it crashed. Why did it crash? Can't concat str to bytes. That's the error message. You tell me what's going wrong. Can't concat str to bytes. Something with, we had one slide on this, very important, yes? Yeah, exactly. So apparently here we get a string as the result and not, yeah. So we said we send this back as bytes, right? So this is really important, but you usually get good error messages. So you can't just concatenate bytes and a string. So we just encode it here, and then this error should be gone. And let's go back and reload. Voila, It's not exactly what we expected, right? Now we get the HTML as text. Okay, but we already know that. That's easy to fix. Let's do the following. Let's have a default status code and media type. So by default we want 200, I think, and I think yeah, let's say 200 okay, and we want text plain. That's what we did. And now, I mean, this should be, let's go back to that slide where I had that here. Oh, I think it was here. Now, we have to tell the browser what I'm sending you now. Please interpret this as something. The browser doesn't do it itself. I said I now send it as text plain, so it's just showing me plain text. That's what I told it, right? Here it says headers, content type, text plain. I should say this is HTML, interpret it. And when it interprets it, it will actually show me a heading, my first search engine. So I just have to change my server to do that. But that's easy, right? Let's just set the media type according to the suffix of the file. So if you run a real web server, that's standard stuff, or you can configure it. Here I'm not saying please interpret this as HTML. I'm just taking the suffix as a hint. It's .html, so please interpret it as HTML. That's the normal way to do it. So let's just do this. So if it ends with HTML, we set the media type to text HTML. That's it. Default is text plain. And now all we have to do here is just insert the media type. And here in our message, we just take the status code by default. And let's just, yeah, we said alles supi is better than okay. Okay. And okay, let's just do that. Let's start the server again. Let's run it again. Bam. Now it worked. Now it interpreted it as HTML. And it's just, let's just look here what it did. Alles supi. Here's the response. And I can look at the response in raw format. So I actually send this. But now let's go back to the headers. Now I said 89 bytes interpret as text HTML, right? And then it's displaying it like this. This is what it was. Okay, and there's a new line here for some reason. Is that new line also in my file? Oh, why? Why is there a new line?
It's the Fort Unix convention.
Ah, yes, yes. So there is a new line here. Ah, yeah, that's probably true. There is a new line which is not shown here. Yeah, so interesting little details. Okay. Is there anything else? I think there's something else which I wanted to... There's something else, but I wonder where it's written. Something I wanted to show you. Request cookies. We will not talk about cookies, although that's also an interesting. I'm looking for the info about the quirks mode. Actually, right now it's in some mode. But where is that info I'm looking for? Anyway, maybe it comes back to me. So what? Now I requested the file that exists. What if I type? Yeah. Now I just get file not found. But here it says 200 alles supi. Okay, and it just sent back, our default was text plain, file not found. Why do I get that? Because I wrote it here, right? I said if file not found, file not found. Well, that's also easy. I mean, look how easy it is now to do, to make this stuff real. I just say, no, the media type is fine. I mean, now I'm sending back a text message. See that I very easily, and you can do this, and you should do this, also send back an image or something, right? You want to send back a meme or whatever, you just set the media type to image, JPEG here, whatever, and the response is an image, and then the display will be an image. But I'm fine with text plain, it's the default, but, and let me set Nixstar, okay, 400, Nixstar, okay, not found, whatever I like. So, let's do that. Now I get the same message, and now I get a 404 here. It tells me, okay, it doesn't exist. I get proper codes now. And also for the fav icon, it now gets a 404. 404, if we go to Wikidata, I think 404 is also a, yeah, Q404 is HTTP 404, not surprising. So what else? What else? So now we have HTML. Okay, and let's add a bit more to our HTML page. Now I have a running server, and now note the following. Let's okay, my first web page in 1990s look and feel. Yeah, this is how web pages look in the 90s. Why is it displaying this as red? Because AND is actually a reserved symbol in HTML, XML word. You need to escape it like this ampersand. That will actually show. And now I want an input field. And yeah, let's, I don't need a value. What do I want? I want to have its size maybe 40. Let's just see what happens. Now notice I changed the HTML plate. I don't have to restart the server now. I'm just changing this. And now let's go here, search HTML. Now I get the new page, right? I didn't have to rerun my server. Now I'm just changing the content which is being served. Now I get this 1990s look and feel. The ampersand here is right. I get my search field. Let's now I can write HTML here, right? Let me just put a placeholder here and write something here. Type your query, and I think it should be a slash here. So now I can just, yeah. Now I get search engine stuff. Now, I mean, I'm just sending HTML. The browser is interpreting the HTML. I don't have to write code for this. I don't have to, my server is still running, working, doing its work. So now I'm just working on the web design part of the problem. So, and we're not using any libraries or anything. We did it all by ourselves. So we have all the basic elements here, a div here. We will look at that in a second. So now I can type my query, and nothing happens. So let's also have a search button. How do you do a search button? Like this. It's also an input thing. Let's just do that. Now I have a search button. Okay, let's search. Nothing happens. Okay, that's the next part. How do we get something to happen when I click on search? I mean, we now go full round. I have a query, I search, my server does something, sends back the result. And now the exercise sheet, I will talk about this exercise sheet in a second. But let's implement that now, or let's go to the slide. Now we want to have action for the search button. Okay, before the action, we have to make our web page nicer. How do we make it nicer? I will just add one element now. I mean, this is now 1990s. Now I can do all kinds of stuff. How do I don't know. Maybe I want to make this here blue or whatever. Or I want to make this larger. How do I do this? I have to specify a style sheet. And I do this in the header section here. Oh, one more thing. Here it says Wikidata in the tab. Here it just says contains the URL. If I want this to have a title, I should put it in the head. My first search engine, I'm just taking the header here as the title. Now watch this. Now this is the title. The title, this is on the page. This is what's displayed in the tab or other programs. Okay, and let's give it a style. So now I'm linking a style sheet, which is typically called like the main file with CSS, cascading style sheet. Let's go to the file. What's style sheet? That's a separate file which says how I want my page to be formatted. It's also very simple, but a huge standard by itself. You can just study CSS for the rest of your life. It's huge, very interesting. Here's just how it works, basic working. Here's just a tag, H1, right? We have seen that. H1 is just specifying first level heading. This just says first level heading, please put them in blue and boldface. Yeah. Let's just do it. And let's now we added search CSS. And now let's just, I don't know, let's take the paragraph and make it, I don't know, red. So let's see. And now the paragraph becomes red. I'm surprised that it becomes, why did it become red? I mean, how did that happen? Now you see here, now it's reading 4 files. It's also reading the search CSS, which it, yeah. So it asked for, please give me, I mean, I already wrote my server that way, whatever. So it sent a GET request for Tura88 search CSS. That file is on my system. It was returned. So, and here's the response. So it's in color red. But now I'm really looking for it. It should complain because I sent this as text plain. I should have said this is a style sheet, and it should complain some. Oh, here it complains. There's something red here. No, that's just the fav icon thing. Does somebody have an idea where the complaint is that this is not the right content type? It should complain somewhere that I sent this as text plain and not text CSS. And I'm wondering where that is. Request, it's complaining nowhere. And I know that there is a mode where it... Does anybody have any idea? Some web developers here or people who are... I was expecting the message to occur here and that you should... Okay, I know one thing, maybe I can provoke it, because let me just do the... No, this is not correct, right? There should be a... Yeah. Let me check that. That's actually what you should do. At the top you should say this is HTML, and now let's try that again. Okay. Now at least it's not red. Why is it not red? Now it ignored my search HTML, my search CSS. Let me see that. Where is it? In my... I have to do it again. Search CSS. Response. Where's the error message now? You see it's quite... okay. The style sheet was not loaded because it's MIME type, text plain is not text CSS. So it's even telling me why it did not load it. Browsers are very lenient with all kinds of mistakes because people writing web pages and stuff, they make so many mistakes. One way to do it would be, like compilers do it, there's one tiny mistake in your page or in your whole setup, and then the page says, sorry, something went wrong, I'm not showing it. That's how many programs work, but for web, you don't want this, right? You just want the web browser to be very lenient and just maybe ignore some parts and show the rest that works. By writing this here, I'm telling it to be strict. Yeah, be really strict, and if something is not properly done, don't show it. So here I didn't send the right heading for the text CSS, the right media type, so it's not loading it. We can fix this very easily here. If the file ends with CSS, give it the right media type. Now we have to restart our server. And now when I reload, it should be red again. Yeah, and now it's just complaining about the fav icon. Okay, that was that. And let's maybe make it blue. I think that's... And one other important thing that's very... web browsers are doing a lot of caching. When I have the... Which means... maybe I can... Let's just close, let me check that whether it works, might not work. Now I close the development console. I can reload here. Let me just turn this red now again. Oh, it's turning red, okay. Depending on what the browser does, it may or may not reload it because it has already loaded it before. So for web development, that's a super important tip. Please remember it. Open the development console. When you don't want your browser to cache stuff, open the console, also for other pages, F12, and make sure that disable cache. Then it will reload everything from scratch. You made a small change or something, you really want the newest content, open the development console, disable cache. Here it reloaded it anyway. I'm a bit surprised, depends on the browser. Now it's blue again. Okay, now we have style. Why is it called cascading style sheets? Because, there are many ways to give rules. You could have another rule later on, and the most specific rule wins. That's cascading. You can nest these sheets and so on, and it's used a lot. It's a huge standard. So for the exercise sheet, at least use some style. Don't use, make it at least 1992 or something, but preferably 2023. So you can spend a lot of time on this, spend at least a little time on this to see what's possible. Okay, why are there 2 gets for the CSS? That's a very good question, right? Do we have an idea? Why are there 2 gets? I think that's a very good question, and I don't think I have an answer. Does anybody have an idea? Why does the browser send the get twice? I don't know. Let's ask the Oracle if it's... Why does the browser send the GET request for search dot... It doesn't have any context, but twice. Let's see if it's... Okay. It's interesting, that would have also been mine generic reply. Browsers do all kinds of stuff to prefetching, opening connections just for the future, sending it twice to check whether it high latency. I think the first one is a good one. They check. So just sending it twice to see. Okay, that's one explanation. Let's go back here and let's maybe go back to the slides. So it's not we don't have the definitive answer, but the browser is doing it to check something. Now we want something to happen when we press the search button, right? Nothing is happening right now. And today we will do it the 90s way. That's how it started. That's also how you should first do it. I think it's complex enough for this first sheet. Let me just say that again. The individual parts are all simple. HTML for itself, CSS for itself, writing a socket communication, basics for itself, networking. But if you put all these together, bytes and strings, so many things interact and row, right? That's why it's good to start with the simple stuff. Let's just put form around this. So form is like you fill out a form. And this looks like a form, right? It has a field. So that's where this notation comes from. So let's just put form around this form. And let's indent it here. And let's close the form. Bam. So that's all I did. I put form around it. I don't have to reload my server. And that's just, okay. And now let's type something and do search. Ah, now something happened. Now I got a request for search HTML question mark, and it says search HTML question mark not found. So just by putting the form around it, something happened. And now I think I think what I have to do here, let's go on the slides. I have to say, I think I have to give this I'm not entirely sure. Let me see what happens when I give this a name. I say name query. Let's just see what happens if I give it name query. Let's go back here. Let's reload this. Let's do, here's our search log. Okay, now what happened? Let's go back. I typed XXX. I clicked search. This is what my HTML says. It says here's an input field with context. It has the name query. And here I have a submit button, and it's all in the form. And what happens when I click on search is that it will send a GET request to the server of the form, question mark, name of the file, question mark, this name here, query, I put query, that's why I get query here, equals the content of the search field. So this is now what my server gets. And this is what my server gets, and what does it do currently? Well, it just interprets this as a file name and looks it up and says it's not found. So now we have to change our server to interpret this correctly. And what should it do? It should interpret this as a query and then return the proper page. And so let's make that change. Okay, we have to go back to our server. So and now check if we have a query string of the form query equals blah blah. Okay, let's do that. Query if, maybe if, right? If request starts with, no, that's not what we, if, maybe I should, if the request ends with the query string of the form query equals blah blah. Let's do that. Okay, it should now be if, I think I need a do I need a regular expression? Yeah, I don't know what if request. No, it doesn't start. I have regular expression here. Okay, let me. If RE match. That's also not what I want. What do I want? I want to know if it contains a query. Yeah, this I don't need. So if it's, I'm sorry for the confusion. I'm back here. So let's see, I want to know if there's something. I mean, it's now, I want to process something like this. And what I want is, I want to split this off and get this here. This part is what I'm interested in. Okay. If this is this, now how do I remove the part after? Actually, I just want to find this substring. How do I find the substring in? Yeah, I think find is correct. Request find is. I just want the position of this. If and you can help me or write it in the chat if you know how to do this. I want to. So if this is, then I want to. Now I want the request to be just everything until. Okay, the query is now. Yeah, what's my query? It's everything after the position plus 6 or something. Yeah, that makes sense. And the request is everything until the position. Okay, and now then I should print that I have a query. Okay. I think that looks good. Now we checked, is there a query? If yes, remove this part. That's what I wanted. Remove this part and just print the query. Let's do nothing for now with the query. Let's just see what it does. Let's go incremental here. Let's type something. Bam. Okay. Now it just, where do I have it? Yes, here. This is correct. And now it's showing the web page again because I was asking for search HTML. Okay, now I have to do something with the query. How do I do that? Interpret as a file name. Now that's the last important part for the exercise sheet. That's something which you don't do nowadays anymore, but as a first step, I think in some contexts you still have this. Now I want a page, and let's do it the way Google always did it and still does it in some form. I somehow want to have the same page as before with my result. So now I click on this and I want to have a version of the same page but with the result added, right? That's basically how Google works. I'm going here to Google, I'm typing something, blah, blah. You always, oh yeah, okay, you don't get a hit for everything. Let's do blah, blah. Okay, and I get this, right? So I'm typing something else here, and I'm getting something else. So I'm getting the version of the same page and the results at the bottom. This is what we want to do, and we do it as follows. So in my page, I'm just putting a placeholder, like a template, and now I'm changing, if there was a query, I'm now changing that into the result. And let's just do that. You will see it when I do it. Let's, so if there was, no, I don't want suggestions here. Let me disable them. If there was a query, replace, if the page is search.html and there was a query, replace result by the result. That's what we will do, right? We will, so let's just do that. If request is search, and I think we should always set the query to none by default. I think empty string is not nice. Let's do 1. And query is not none, exactly. Then, so what do we want now? Now we want to, yeah. So what should our result be? Let's first write a result. To do, put the result here. Let's just first understand the mechanism. So if it's like this, and now I do in my page, so I've already loaded the, just understand where we are now. I've clicked the button, So now I've got a request for, oh, it's already, no, it's up here. I've got a request like this. This is after I click the button. So I've stripped this off, so what remains is I'm just loading search HTML again, but I have XXX in my query, I do something with it, and I just want to replace the % result in this page by my result. So all I do here is, now I change something here, is in my response, and you will need to do this for the exercise sheet. I just have to replace the result, and I think I already encoded it here. Okay, I think it's this we better do here now. Turn encode the response as bytes, so that way I don't have to deal with bytes here. Yeah, let me just do that, result by result. And otherwise, I don't want, yeah, let's just do this for now and see what happens. And so, yeah, this is not what I want, right? If I don't have a query string, now I get the result here. So that's easy to fix too. So if I'm not in that case, no, I don't want the, I think what I want is, so you see these suggestions, you have to take them with a grain of salt, right? This is, yeah, I want to replace it by nothing. So if I had a query string, I want to replace it by my result. I will compute it in a second. Otherwise, replace it by nothing. Let's see whether that works. It doesn't. Why not? Oh, because I didn't restart my server. Okay, the result was not replaced. Why not? I think, first of all, I should only do this if I'm here. I'm a bit confused. So if query is not none, so if I have a query, I do this. If I don't have a query, my result is just the empty string. And in any case, I only want to do this for, I want to replace % result by result. That looks good to me, but it doesn't work. And you have to tell me why. I don't want this here, and I don't understand why it's still there. I mean, it's clear that it's there because I put it here, but now I was expecting that if my request, yeah? Where?
You still have the query in the URL bar in the browser.
Oh, that's the reason. Thank you. Yeah, yeah. Too many trees. Search HTML. Still there. Yeah?
We have to replace it anyway because we put it there anyway.
So where's the mistake? Which line of code should I change?
140.
Yeah?
I think we just have to set, either we replace it every time with nothing, so we set the result, default result all set as well, or we replace in the other case just the result with the empty string.
I don't understand. Why am I not in the...
No, because we didn't serve.
sorry, I have to reassign what?
Replace is not replace.
Oh! Stupid. Okay, I'm just, yeah, thank you. It still doesn't work because I didn't restart the server. It's a good example. I mean, yeah, now sometimes I have to restart the server. When I just change the page, I don't have, now it will work. I'm pretty confident, yes. So, yeah, you can get confused very quickly. So far it worked swimmingly. I'm surprised that we didn't have more problems. This stuff just gets complicated because you have so many things interacting with each other. But we are doing pretty well so far. So let's just see. Now I type something here, I press search, put the result here. It works. So let's put the result there. That's all we want to do. Let's put the result there, and let's put a piece of HTML there. So I want a piece of HTML, and let's just do it like this. What do we do? P or not P, yeah. Let me put a format string here. Your query, or let me just write query. Let me just put the query there again. Query, no, that's the request. No, it's the query. That's the query above. Let's put the query there in a paragraph, and let's also put and then the result. Yeah, result. I haven't computed the result yet, and but I think this is almost the last. So I'm just putting this in parentheses so that I can do it. If things are in parentheses and you break the line in between, you don't need an end of line character. And let's make this result string here. And this also result string here. Yeah, and let's also replace this here with result string. Okay, fine. And now I have to compute my result. So what do I want? Let's maybe just take let's just consider it as a mathematical expression and just write eval query here. Okay, and let's maybe put it in a try block, another one. Try result query, except result, I think the indentation level is wrong here, is invalid expression. So that's a very simple web app. I type something, little math question, I evaluate it, invalid. Let's just see how it works. Let's just, okay, let me just do some tests here. Oh my, I get some errors here. Trailing white space, terrible. Let me just fix some problems here. I don't need sys, okay. Re-imported but unused, okay, I don't need regular expressions here. Too many blank lines in 69. Okay, there shouldn't be a blank line here. What else do I have? Do not use bare except, okay. Okay, I should use exception, okay, wonderful. And 120, f string is missing placeholders, thank you. Yeah, okay, if I don't have placeholders, I don't need an f string. Okay, now it compiles and I don't have check style errors. Let's restart the server and let's see. So yeah, this is really, I have the string here. This is in the static case, so let's type something. 6 times 7. Bam. Invalid expression, okay, and it's blue. Okay, why is it blue? Because my paragraphs are blue. Okay, let's fix that little problem. I only want the first paragraph to be, make first paragraph blue. So how do we do that? Yeah, first child blue, okay. Yeah, you can do a lot with CSS. Now it's only, oh, but that's the second one, okay. First child apparently is not the, shouldn't be, is it nth child 1? Does it start at, maybe it should be 0? Oh, now none of it is, okay. Does anybody can find out how I make the first paragraph blue? For now it's not.
Why do you make a paragraph blue when you can use a class or a name?
Yeah, that's stuff you can do for the exercise sheet. We are doing very simple things now. But isn't it a paragraph? So I'm not understanding why it doesn't make the first paragraph blue. Okay, but. inside of P, but I don't have something inside of P, right? I mean, huh? Yeah, okay, let's do that, okay. So that's my look and feel. Let's do that. So I can also do that. I can give elements an ID. Yes, so look and feel, that's one way to do it. Now I just make the element with that ID blue. Yeah, and so that's one way to do it. Okay, back here. We are almost done. Now what's happening here? Look at what it sent. I typed, let's go back to my search page. I typed 6 times 7 here with spaces. And now what it sends is 6 plus times plus 7. Why? What are the pluses? I think that's the last thing I have to tell you about. So we did this template thing here. Yeah, in a URL, you can't write everything in a URL. The stuff you can write in the address bar is quite restricted. Here's the set of characters, so it's typically the letters, dollar, %, a few special characters, but no space, for example. And then there's no space in a URL. And here we have a space in the input, and we want to send it. Okay, so, which means when this form sends its request to the server, it will somehow decode this, and when we interpret it, encode it, we have to decode it again. Now that's now not UTF-8 encoding decoding, it's URL encoding decoding. These two things together are also can drive you crazy. You have string to bytes, UTF-8, different encodings, and then you have URL encodings, and these come on top of each other several times maybe. If you see funny things in mails which are strangely formatted, it's typically because of this. It's also a whole world, a whole rabbit hole to go down to. Very interesting. We will talk about this more in the next lecture. So in particular, you can't have special characters or spaces, as I said. For the exercise sheet and for now, we just do a very simple encoding. I will just say, okay, I know that the plus, so space is encoded as a plus. So let me just revert the pluses to space again. So let me just do that in my code. So, and you should also do that in your code. You can also use URL decode if you like. So let simple URL decoding of query, and what do I want? I want, and I think I should do that up here. Yeah, let's just do a simple URL decoding of query. Query is, yeah, let's just replace all pluses by space. Let's see if that works. That's a simple one. Okay, let's do that again. 6 times 7, 42, it works. Okay, 6 times 7, so it did this here. It extracted the query, it replaced pluses by spaces, it evaluated it. Now I think this is internal. I am seeing no requests from the outside. I will not do this now. I did something terrible here. Nobody said something so far, but I did something extremely terrible. I wrote eval in my server code. The user types something and I evaluate it. Oh my. We will talk more about this. What if I write rm remove rf star, some command here, and then it executes it? I don't know. Okay, it says invalid expression, but I tell you I could write something here which will cause my Python server to execute code and arbitrary code. And you don't think about this when you program this, but you shouldn't put. So the minimum I should do here is look at my query. If I really want to do it, does it have a certain form? If not, then I say you're not supposed to do this. So this is terrible code. Right now, I'm not showing it. There would be a way to write something in the query field which would prompt my server to actually delete all the files on my system. This is just for your reference. You can read it yourself. I think we are done with the. We have written a whole web application, which is pretty impressive. Oh, I think we can't do the plus, right? Yeah, plus does not work because the plus is now also encoded as %$B. Let's also fix that last thing. Because space is encoded as plus, so I also have to encode plus. And plus is encoded as %B. So this should be reverted to plus. Let's do this last little hack and see if it works. We have to restart our server, and we have to, yeah, this now works. So now I can type arbitrary expressions here, divided by 5, and search it. Okay, divided by, I would also have to, I don't do this now, but I think with plus and times it works. Okay. So we have written a very simple web app with everything that belongs to it, that does something, returns it, shows the result. Let's quickly go to the exercise sheet. If I find it here, the exercise sheet will be to do just this, as I showed you. You get the starting code as starting code, just as I did today in the lecture. But now what you should do is what you did for the last exercise sheet, but just in a web app. You type something here, the beginning of something, and then the result is just like I showed at the beginning of the lecture, prefix matches of what you type. And for this exercise sheet, we will do it in the static way. You type something, you press a button, and then you get the list of matches for what you type. In the next lecture, we will do it dynamic as you type. And then you have a super cool web application. This is a lot of text, but just to help you. And you should pay attention to really understand what you are doing. There will be a lot of mistakes on the way. I also had some today. You should do proper handling of all kinds of cases here. It's explained here. So you're basically connecting this web application stuff to the last sheet. One last thing, you don't have to do it for this sheet. You should also connect this to our SQL Sparkle thing by just display. I mean, this was, let me just go back here. Let me leave this and I mean, what you are searching is these entities, right? So that's what you will do. You type something, just like for the last exercise sheet, you get a list of matching entities. In our SQL Sparkle lectures, we also had these entities and we had information about them. So what we will do in the next exercise sheet, you type something, you do not only get Freiburg and Breisgau, but you also get triples for Freiburg and Breisgau, which means your web application will just ask a Sparkle query and show the corresponding triples. And the Sparkle query is, of course, translated to a SQL query, which is then executed. And this is very typical for web applications. So you will have all of this together. You don't have to do it for this exercise sheet, but if you want, it's actually not a lot of code, you can already do it. And for the next exercise sheet, it will be part of the sheet. And then you kind of have everything we did so far in one application, which I think is really cool and you will like it. Let's check if there's relative path search server. Let's reply to that. There was a question whether, let's just check that. Can we render our own Python script here? Server.py. Yes, there it is. Yeah. And you have to pay attention, and that's part of the next lecture also. Now I could ask my system to render all kinds of files, right? If I don't pay attention. Probably if I write this here. I will not do it because then you will see our... Is there a secret information in there? Oh.
Full names of the people.
Full names of the people. Okay, so I shouldn't do this. If I would do this, I think it would... Is there another file which is maybe let's do proc CPU info. This is, I think, a file which is... okay, it doesn't like the slashes. Okay, there's some protection here because I've done something not quite right, but you really have to pay attention. It will be a topic of it will be part of the next lecture. Any questions for now? So a little over time, but I think we did well. Any question? Please do the sheet. Otherwise, just by hearing it, you don't learn it. You have to do the sheet, but it's really fun. Okay, that's it for today. Have fun. See you next week. Bye.